In the FHIM-MDHT Model-Driven Healthcare Tooling Vision video, we showed how FHIM-based MDHT can improve and simplify the design time SIGG Standards Implementation Guide Generator process. The training objective of this FHIM-MDMI Model-Driven Message Interface Runtime Translation Tool video is to show how FHIM-based MDMI can improve and simplify the runtime heterogeneous system information sharing data translation process. The situation is that runtime semantic data mapping and structural transformations are the universal approach to improve intra- and inter-HIE Enterprise Health Information Exchange Network interoperability across heterogeneous system standards and standards versions. This is especially true when ancillary systems, subnetworks, and components are added across time, across clinical domains, and across enterprises. There are a plethora of clinical input forms and formalisms that can lead to FHIR, where FHIM can act as a canonical data element mapping Rosetta Stone among information models and information serializations. Any industry, including healthcare, that has make it fast, deal with high volume, and runtime translation requirements can benefit from a tool like the Object Management Group's Model-Driven Message Interface tool called MDMI. MDMI uses FHIM as its canonical computable representation, referred to as its referent index. The referent index is mapped to each alternative information exchange representation to harmonize data sharing among heterogeneous systems. Different standards and varying standards versions, MDMI setup can use the MDHT design time model repository to specify semantically correct translations from one message serialization to another. This can be a practical way to achieve data sharing interoperability within and among distributed SOA communities of independent enterprises and legacy systems, where each participant builds and maintains one map of their data elements to the MDMI referent index. MDMI decomposes each data exchange into its syntactic elements, where MDMI maps the semantic data terminology elements to uniquely identified business data elements in the MDMI data dictionary. This design time referent index mapping makes the MDMI runtime translations fast. We must be cautious because one-to-one mapping can be confounded by differences in data types, differences in pre- and post-coordination, differences in concept granularity, plus lack of data provenance consistency and completeness. Example, in 2010, Southeast Michigan Health Information Exchange, SIGG, won a $2,988,000 contract to exchange electronic medical records with the U.S. Social Security Administration in Detroit, Michigan. This award came to SIGG in partnership with its fiduciary Southeastern Michigan Health Association, SIGG, and its collaborative IT partners Sun Microsystems, CNSI, and Group. The project used MDMI to automate the process of filing Social Security disability insurance claims in the Detroit metro region and accelerated the process from 457 days on average to approximately 6 hours. In summary, quick fact number 1, data sharing interoperability can reduce costs, increase patient safety, and increase revenue by automating interoperability between disparate systems. MDMI-type tools improve communications help reduce errors, and provide an agile way to address future data representation changes. Quick fact number 2. MDMI-like tools can provide a solution for the pervasive and never-ending problem inherent in business processes. The problems use different electronic data sharing paradigms, such as but not limited to HL7 FHIR, CCDA, and V2. MDMI can provide the means for managing the costs of integrating disparate systems to provide agile business and technical value on an aggressive schedule. Quick fact number 3. In healthcare, the data mapping and transformation approach can be positively influenced when FHIM is used to manage the data sharing dictionary and domain syntactic patterns. SIMI is used to manage detailed clinical statement data sharing syntax. Solar is used to manage data sharing semantics, and FHIR is used to manage data sharing service-oriented architecture APIs, platforms, and components. Benefit of a consistent and requirements traceable, standardized FHIM, SIMI, Solar, and FHIR reusable modeling foundation is improved computable interoperability, also known as interoperability across time, locations, systems, and care contexts. This assumes that the reusable MDMI translation stack is standardized and is widely implemented. Note that other FHIM training videos are available on the YouTube FHIM training channel. This is the end of the FHIM-MDMI runtime translation tool video.